This lesson will cover some chart types with fairly specific applications: the box and whisker, histogram, and stock chart types. Understanding the box and whisker and histogram plots requires a modicum of statistical understanding. Both of them segregate a set of sample data into different groupings. The histogram simply puts them into percentage blocks of data for visualizing how the data is dispersed to mimic a probability distribution function. For this dataset, I have a random sample with about 200 items. Let's imagine that you work for the IRS and each one is a reported income from a tax return. I might be interested in seeing what the distribution of income looks like for this sample, and a histogram is perfect for that. I can select the dataset, go to Insert, and under the Statistical charts, I can select the histogram. The histogram creates bins and then counts the number of items within each bin. The only required input is the values to evaluate. There are no selected labels, which makes manipulation of the chart a little bit different. Manipulating a histogram's chart view requires modifying the axis. Right-clicking on the axis and choosing Format Axis gives us the tools to do this. By default, the axis options define bins automatically, which might not be ideal. For this, perhaps we want to look at how the incomes look in $5,000 increments. The automatic grouping has done them in $5,600 increments, so I could select the bin width and change it to $5,000 bins. Or I could specify how many bins I want to see using the number of bins and break it into 20. Each bin gets spaced equally, so I can see how the values get interspersed. Histograms do come with a category. I've gone ahead and assigned some categories in column D, so I can look at how those are interspersed by adding them to the dataset, editing my axis, and changing my axis options from number of bins to by category. In this scenario, each gets a weight based upon the amount rather than with a count like the standard histogram, and the result is basically a standard column chart. An alternative form of the histogram overlays a cumulative distribution line on top of the bar chart. So I'll reset my number of bins to 20, and I'll modify my chart type to include my distribution function. This simply tells you how quickly you reach 100% as each piece is added in. The histogram provides a strictly quantitative look at how a sample is distributed. Let's go look at the box and whiskers plot, which takes the statistical view in a slightly different direction. A box and whisker plot looks at how a dataset compares to a distribution. To do this, it takes a sample dataset and then looks at how the data falls within different quartiles. The 25th, 50th, and 75th percentiles create boundaries where the range from the distribution's 5th through 25th represents the lower whisker, the 25th to 75th represents the box, and the 75th to the 95th represents the upper whisker. Any sample points observed outside of this estimated range are classified as outliers. The resulting chart can give you an idea as to how different distributions compare to one another and how variable the data is, as well as helping you see how many outliers appear within the data. Each data series represents a different sample, so I can look at the construction of this chart and see that each of the entries is its own data series. This allows me to easily add or remove pieces from the box and whisker plot. Both of these chart types are valuable for statistical analysis of datasets with slightly different purposes. Let's move on to the stock class of charts next. The stock class of charts on the Insert tab falls under the same dropdown as the waterfall charts. However, stock charts are far different from the waterfall chart. Stock charts cannot be created as blanks. Trying to insert a stock chart without any data selected will result in an informative error. The simplest stock chart uses the high, low, and closing values of a stock for a given day. I've got a sample dataset that I've randomly generated here to show what this might look like. The order of these series matters. For the high, low, close, the first entry must be high, the second entry must be low, with the final entry being close. The next version replaces the open value with a volume. Similarly, order matters, with the first value being the open, followed by the order for the prior version. In this tab, I have all 4 charts for this subset of data. On each of these, the high and low values will create whisker-like plots out from either a center box or a marker. For close-only charts, the close is shown as a single point within each line. In this way, you can see where the stock settled at and how the high and low points varied around that point. The open, high, low, close represents a change from the open to close as a box. White indicates that there is an increase from open to close. On point 3, the open is just above 15,000, while the close is just shy of 16,000. The result was an increase, so the box is white. On 4, there was a decrease, so the box is black. The final component that can be added is the volume component. The volume high-low close simply adds a volume chart on top of the rest of the graph. This indicates the amount of volume that occurred that day on top of the standard high-low close chart. Similarly, you can do the same thing with a volume open high-low close chart, which shows the volume, the change from open to close, and the high and low as whisker points. These stock charts can be fairly finicky to create, and I always advise creating them from scratch. They require at a bare minimum 3 data series for the high, low, and close, and they need to be ordered in that precise way. The Chart Insert tool has good guidance when you do try to create a stock chart. We've now covered how to create each of the standalone chart types and how each can be used from a broad perspective. Before you move into the remainder of the lesson, Exercise 5 will now be available to you. In it, there are some subsets of data with brief descriptions within. Your task is to create charts suitable for each data set and write down why you used the chart you did. The solution will include some different chart types that I would have used and my explanation for using each of them. This is a fairly open-ended exercise, but the intent is to get you to think about your chart selection while also learning how to use the chart tools themselves. Our next lesson will dive into some of the more common customization options that are used in charts.